Okay, I guess we're live. I wasn't sure if there was going to be a little intro or anything, but we're happy to dive right in. Well, hello everyone at nwHacks. Really exciting to be here. My name is Harish Rezingani. I am the head of developer relations at Covalent. Also a proud UBC grad from way back in the day, 2006. I'm just aging myself here. And I've also got a colleague with me, Emmanuel. Do you want to give a quick intro?
Hi guys, Emmanuel here, developer relations at Covalent, joining you from Lagos, Nigeria.
Yes, Emmanuel is one of our sort of all-star cast that got brought on through what we call the Alchemist program, which you may have heard Ganesh talk about during the Q&A. So we do have most of our team based here in Vancouver, but we've got talent that we can pull from anywhere globally, which is sort of what the ethos of the Web3 space is, to have this distributed, decentralized organization as a core part of your project. So I'm going to dive right in. I'm going to talk a little bit about the Web3 space, and just to give folks a bit of a frame for the any projects they might be thinking of building in this space here. It is a sort of a new term that's being used, and I know folks are coming from very different technical backgrounds. So we'll spend a little bit of time just understanding what Web3 is, and then Emmanuel's got a couple exercises to walk you through where you will set up your first sort of Web3 wallet, your crypto wallet, and we'll take a look at how to analyze some of the underlying data associated with your wallet. So I think that'll be a cool way to sort of continue your journey to explore this space if it's something that you're interested in. All right, let me just... So what is Web3? Well, if you think of the first phase of the commercial web or Web 1.0, think back to the period. I know you guys are all young, so this might be really early for you guys, but the early 90s to roughly the mid 2000s, which was dominated by a web of open protocols like HTTP for content and SMTP for email. The products and services in this phase were primarily just digital translations of their analog equivalent in the real world into the online space. So things like newspapers, magazines, photos, primarily static content that was put in the online phase. And this is sort of a phase you can think of as being read-only with the concept of an information superhighway. So fairly static content and really just interacting it in a way to receive information. And then you saw the shift from the mid 2000s to now, which is termed sort of the Web 2.0 or Web 2, which was driven by advancements in cloud computing and in mobile technology, and of course the rise of social media. And a lot of the content from interactive experiences was actually user-generated content. So yes, it's a more participatory internet and a more participatory web where you can think of it as having read-write capabilities, and users can provide content. But the user and the corresponding data became the product that was stored and sold by a handful of large centralized organizations, where participants in the network do not really own any of the network itself. You can think of the drivers in the Uber network. And these are some of the challenges that Ganesh had brought up during the Q&A, and what Web3 is aiming to solve, and why projects like ours are in the space for that mission to sort of provide value to the builders and the participants of a particular network. So that brings us to this concept of Web3 and the promise of a dynamic, decentralized internet where users own their own data. They get to share in the value creation. Some of the key tenets of Web3 are that it's open, built from open source software, built by an open, accessible community of developers, executed publicly in sort of full view of the world. It's trustless. So, network itself allows participants to interact both publicly and privately without having a trusted third party. permissionless, so there's no governing body that gatekeeps or facilitates who joins or doesn't join, and it's composable. So this is an interesting concept. You can think of it like Lego building blocks of open source code, which is being combined to build new applications. And this is a very powerful way to build applications, because with open source, it means that if you do have a problem, it only needs to be really solved once. And what it leads to is these incredibly rapid Web3 development cycles. So there's a great quote, Chris Dixon, who said, think of composability to software as what compound interest is to finance, in terms of the leverage that it provides you. So a very exciting time to be involved in tech and in Web3, because for those of you looking back, if you could have got in the tech space in the early 2000s with the first iteration, how exciting it would be for all the innovation, all the cool projects that were coming on board. And Web3 now provides this with the additional leverage of being able to participate in sort of a distributed, decentralized manner from anywhere that you've got an internet connection. We see that the web paradigm is resonating with developers. It's still very early. I mean, these numbers are small if you compare how many developers are in the current Web 2 space to Web 3. Here's a chart by Electric Capital, updated to April of this year. And they analyzed a bunch of code repositories. They looked at code commits. And this is sort of the trend that we're seeing over the past decade for those developers diving into crypto, diving into the Web3 space. I expect with the innovation that's sort of also taken place this year with things like non-fungible tokens or NFTs that you might have heard about, these collectibles becoming more mainstream, that we'll see even a further jump if we were to trend this curve out for the rest of this year. So we've got a lot of smart people and smart developers looking to the Web3 space and trying to figure out how to participate. But there are some serious headwinds and some serious challenges that are worth noting. So while it is a relatively nascent space, it is still really early. We have seen things start to become a little bit more mainstream with collectibles, but all in all, it's still very early. It's like being at the 1999 or 2000 of the .com bubble back in that day. It is a very complex space that moves very quickly, and there's a lot of noise, so it's very easy to get overwhelmed. It's not surprising folks sort of look at this and say, I see a lot of fads, I see a lot of little trendy things, but this isn't quite for me. So it is an area that where we're trying to focus on to have onboarding ramps that make it easy to join in Web3. There's of course a lack of regulatory frameworks, and there's publicity around crypto-based scams and personas of bros with their insiders using specific slang and lingo. So it doesn't necessarily paint a friendly, welcoming face for everyone to want to join. But it is changing. And I suspect, there'll be a tipping point soon where, we'll see a flood of developers move into the Web3 space. Ganesh mentioned this, concept of fintech and DeFi emerging, and I think you're going to see a lot more Web3 or a lot more developers move into the Web3 phase, especially over the next few years. So, what is this space doing, and then what are we at Covalent doing to help onboard developers into the Web3 space? So, as mentioned, it is a really exciting time. If you ever had an opportunity to join the Web3 and the crypto sort of revolution, if you will, now is the time. There are so many interesting sort of technologies, so many interesting projects, a lot of money being thrown, at developers, at those in the ecosystems to just learn and be part of different projects. So, this year, we've seen, this trend of fintech and crypto emerging. We've seen NFT booms with big brands all jumping in to offer digital collectibles. And we're also seeing governments both publicly and privately endorsing blockchain tech and doing their own R&D. This concept of, central government-backed digital currencies sort of taking a center stage in terms of being part of the conversation. So a lot of traction, a lot of interesting conversations just in the past 2 years have seen a massive increase in adoption and rise of interest in this space. We at Covalent use this as a thought exercise, but picturing 2025, which again is not too far off here, what it would look like given the torrid pace of innovation in this space. So we envision this multi-chain ecosystem, lots of digital distributed ledgers powering thousands of applications, with most users probably even unaware that anything related to blockchain is under the hood. And we'll see those apps in every industry that you can imagine, from finance to gaming to government. And in creating or in this future, we see that there's just an enormous amount of data being created, and it's difficult to access. It's hard to parse and be able to make sense of it. So data interoperability and being able to access and analyze data at scale is going to be the crux of the problem to solve in order to get this mass adoption by broad set of users, corporations, businesses, etc. So with blockchains being these decentralized, you can think of as decentralized computers to some extent, where anybody can write to and can access. The data can be very disorganized. It can be difficult to understand. It can be very difficult to store. And so that's where a middleware layer like Covalent comes into place, where we can take these concepts and try to organize this data so individuals, developers, corporations can actually use it in a meaningful way. So the Covalent API, think of it as just a single unified API bringing visibility to billions of data points. Our motto is one unified API, 1 billion possibilities. So with just a single API, you can fetch granular historical blockchain data across multiple networks with literally no code or very little code. And in this space, we do, we index, or we basically store entire blockchains, all their data, and organize it so that the data is immediately available, so to be able to be consumed and used by developers. If we think of this in terms of a crypto stack, this is a very useful diagram to just sort of keep in your mind as a mental model of this space. So at a very high level, you've got distributed ledgers like blockchains composed of nodes. Developers can access data that's on these distributed ledgers through either running one of these nodes themselves and being part of that network, or using a hosted solution. And with public blockchains, anyone can access this data, but there are significant challenges in trying to do this in a reliable, easy to use, and scalable manner. And so, Covalent as the Google of blockchain when it comes to indexing, and you can think of us as like a Twilio blockchains when it comes to a web service API. That's sort of how we present ourselves, as this middleware data solution that helps developers build all sorts of different applications. So everything from charting and dashboards to wallets to your digital collectibles, and probably a whole host of different use cases that we haven't even come across yet. That's the goal of an organization like ours. We have sort of two core users in mind with our product. So obviously developers is the one that we talk about a lot with our API, but we also have an affinity and a focus towards data analysts, or data nerds, as we like to affectionately call them internally, where being able to extract data in a spreadsheet or a CSV format, and then being able to use Excel, Power BI, Tableau, or any of the other business intelligence tools people might be familiar with. It's definitely a target audience for us, and we want to make our tools as simple as possible, so that a broad group of users with a bit of a technical background can use our products. We're excited to have had the opportunity to engage over 15,000 developers, power over 300 projects in this space, ranging from large enterprises to small startups with our API. And so, we inspire you, hopefully we'll inspire you all to try to use this in your hackathon projects. We'll kind of go through the paces of how to get set up, and then how to incorporate the API into your project. But we'll start with actually even a simpler step where we get you introduced to being able to set up a wallet and be able to conduct some transactions, so you can kind of get a concept of what that process looks like. And again, the token aspect of what we're talking about here is really what powers this Web3 paradigm and economy, where you've got this token reflecting value to both the participants and the builders of the network. So with that, I think that's probably enough talking here. So let's dive into the first exercise. So Emmanuel, do you want to take everyone through the process of setting up their Web3 wallet?
Yes.
I understand for some of you, you might be familiar with the space and you've done this many times, but hopefully for many of you, this is sort of your first foray into Web3, and this will be sort of an interesting exercise to go through.
Thank you, Harish. Thank you so much. So I'm just going to dive right into the first exercise, which is setting up your Web3 wallet, right? So this exercise practically has the premise that you are going to be starting from zero knowledge up to the point where you are able to set up a custodial wallet and then be able to send some Ether from a faucet and then have that crypto in your wallet. So we are just going to go right into the session here. We have 4 steps here. First, we are going to install Metamax for, I'm using the Chrome browser right now. So we're going to install Metamax for Chrome. You could also install Metamax on your Brave browser. And then once we set up Metamax is going to give us a wallet address. That address is what we can use to hold our crypto assets. We are going to copy that wallet address and then change the network to a testnet and receive some test Ether into that wallet address. So, like I said, the premise is that you are beginning from scratch and you have not set up Metamax yet. I am just going to walk you right through how to do that. So first step is to come to Google and then search for Metamax for Chrome. This is going to give you the Metamax Chrome extension that you can install and use for your browser. To be very clear, Metamax is a custodial wallet, and we also have non-custodial wallets, which are practically hardware wallets, right? So for a custodial wallet, Metamax gives you a wallet that's that you can use to hold addresses, and then they give you a set of private keys that you can then have to keep and then be able to use that private keys to access that wallet anytime you want. So Metamax has been added at this point, and then we are just going to go through some very simple steps where we would set up our wallet. And please, it is very important to pay attention to each of the steps. So we get started. For this particular setup, this is a new setup where we are going to create a wallet. But if for those who had already gone through this process before, you are able to import a wallet if you have what we call a recovery seed phrase. If you remember, I said Metamax is a custodial wallet, and that seed phrase is what Metamax gives you as a way for you to access your wallet at any point in time. So we are going to create a wallet and then agree to the terms and just set up a password quickly. Oh, okay. I missed the character there. Yeah, I think lesson learned there, never use a complicated password. So click agree to terms, create. And as against making you watch this video where it explains to you what a recovery phrase is, I'm just going to go show you the recovery phrase and then explain practically what the recovery phrase is meant for. So your recovery phrase is actually 12 words that are very random, right? So these words serve as some sort of password for you to access your wallet at any time. So Metamax, when you create a wallet on Metamax, right? You would have noticed that there wasn't a KYC process where you had to like put in an email address. So what that means is that whenever you lose access to your wallet, say your password, you are unable to recover that account, and that account is lost. But with these private keys, you can always gain keys. You can always gain access to your wallet. So we are just going to copy this. I'm going to copy this. I'm using an online notes to keep a notepad to hold this.
Of course, when you go through this process, you won't be necessarily copying and pasting there, but it's again, if you lose your password and there's an issue with your private key, this is a way for you to always go back and unlock your account. But it also means that if somebody else has access to these seed phrases or these words, they can access your account. So something you definitely want to guard.
Exactly, very important. So yes, so and just to be very, very, very clear, this is going for demo purposes only. So this wallet is not going to be active after this session. So just to confirm your secret phrase that you copied from earlier, you are given the words again, and then you have to like select each of them in the order in which it was given to you. I have copied it from earlier and put it in the browser here. So the first rule was vacuum during an erosion. I'm just going to go ahead, select that during erosion. And then the next set of three words are joke, trust, rose. Joke, trust, rose. I think the fourth word there was scorpion. Yeah, that is correct. And then we have hotel, divide, few, trap, and unique. That is hotel, divide, few, trap, and unique. So if at any point this was not in the right order, it wouldn't have highlighted the confirm button. So I go ahead, click confirm, and there I have my wallet set up, and it's all done. So seeing as I am on Chrome, I can quickly look through my list of extensions and then just spin it here. So this way, I always am able to access it easily. So the next step for this step, for setting up this exercise, is to copy the wallet address and then paste it into a faucet to receive some test data. So back here, now that we have it pinned as part of the extensions, we can come in here. You can just simply click on the address to copy it, or you can come into the window view and do the same thing, right? So this is a faucet. It is a test net where you get test data to be able to probably just carry out transactions, just to understand the entire process of carrying transactions out on chain. So we are going to request for some ETH. It's going to give us 0.001 ETH, which is test it out. That means is that you cannot use it for anything else apart from carrying out test on chain. So I'm just going to complete, click select bots. I'm going to complete the captcha. And then, yeah, one more bot there. Verify. Yeah, I am human. Get it. So it's going to send me some test it. So at this point, we are on the Ethereum mainnet. I am just going to change network here to the Covalent testnet, which, so that was very sharp. But if you had looked closely, you would have seen that it was at 0.001 ETH. It was 0 ETH, and now we just received 0.001 ETH. And also, you can use the Covalent faucets. It's at Guitar. Just to copy the address. Let's just get more ETH. And then just paste the address in there. It usually takes a few seconds. You would get a response from the server that some ETH has been sent to you. So there, our balance should increase when we change. Come back in there. Then okay. I think the transaction is still ongoing. It has to verify the transaction on chain, and then when it does that, it's going to increase the balance. So
it might take like 25 to 30 seconds for that transaction to clear. It's one thing to keep in mind when we're talking about networks like, for example, this one, the Ethereum network that we're using. some blockchains are really quick, and your transaction might only take 2 to 3 seconds. Others, like this one, which is probably the most well-known and largest sort of public programmable blockchain out there, it might take 25, 30 seconds for that transaction to settle.
Great. Thank you, Harish, for adding that. So the last step is to share the wallet address and send some test tokens, right? I am just going to copy another address that I have set up already, right? And then show you the process of sending tokens from one address to another. I think, okay, that transaction has still not confirmed, but we still have 0.001 ETH. So we are just going to go through the process of sending ETH from this address to another address that I copied. So all you have to do is paste in the address. You can also paste in an ENS name, which is the Ethereum naming service, right? We could just be something as simple as demo.ed or any name with a .eth extension. So we have 0.01 ed. I'm just going to send just a fraction of that, 0.005 ed. So when you are making transactions, you get charged a gas fee. So the gas fee is it's charged for transactions when you're sending transactions on chain. Yeah, it is a way of ensuring that your transactions gets picked up by validators and then gets completed. So we are just going to confirm this and then.
So while that's pending, Emmanuel, why is there a gas fee? Why do we have to pay something to be able to interact with the network?
So practically, the blockchain has a collection of nodes and has these nodes being controlled by different users here, which is the core concept of decentralizations, right? And then we actually use a particular consensus to verify that transactions on chain is correct, and that is called the proof of work. And then the proof of work consensus is carried out by validators. So whenever you carry out a transaction on chain, right? So these validators have to like pick up each of these transactions and add it to a particular block. And for them to be able to do that, they charge a gas fee, right? And then that gas fee, they actually get a fraction of it to just validate your transaction that you are not trying to do anything malicious on the chain. So that is just a high level overview without going into the technical nitty-gritty of all of it.
Mm-hmm. Yeah, because it's a public blockchain that anyone can access and anyone can contribute to and write to. The concept of paying something basically helps spamming that network with the content where you're not charged to write to it. So it's the same as the tooling behind sending out mass emails. There's actually a little bit of computational work required so that it prevents you from just being able to send 100 million emails as spam with a click of a button. So same idea. You want to ensure that people aren't just spamming that network. There's actually a cost to be able to transact with it. Is there a cost to just read data from the blockchain?
No, reading data, no, there is no cost to reading data. So, and to just demonstrate that right now, the transaction that we actually carried out, it actually got confirmed, right? It has been sent. And then just to show that again, when the transaction was successful, it actually gave us a result. And there is a service called Etherscan where you can actually see all transactions on chain for every block, right? From Genesis block to like the latest block height. And then for that particular transaction where we sent out 0.005 Ether and then paid gas fee, this is that particular transaction. So that is all for exercise one, right? And then it goes further to underscore, how blockchain technologies work here and where Covalent sits in that whole pipeline, right? So we have the blockchain itself, then we have the nodes where this information is read from on chain, and then Covalent sits in that very sweet spot as a data layer to show you, just as I had shown you on Etherscan, that particular transaction. I'm going to use Covalent to demo how it is possible to, view that same information. But the interesting thing right now is that it is not just possible for Ethereum, but also across other chains.
So just before you jump to that, Emmanuel, if you go back to that slide, so let's just make sure we understood the exercise that we just went through. What blockchain did we use?
So we actually use the Ethereum blockchain.
And which particular sort of variant of the Ethereum blockchain?
So that was the Covan testnet. So we have the Ethereum blockchain, which we call the mainnet. The mainnet is where all transactions actually have real world value, right? And all Ether actually has real world value. So for every Ether that you spend on the mainnet, you are actually in quotes spending a in quotes, like I said, spending a version of fiat, right? Just as you would spend real world money. But you can think of the Covalent network as being in a movie and then using prop money probably to make payments. So that is what the Covalent network is, and that is what the Ethereum mainnet is. So the transaction that we just carried out just now for the exercise one, it was on the Covalent testnet.
Awesome. And then what about the nodes? Like, how did we access the, how were we able to use Metamask to write data to the blockchain? So who's providing the node here?
So we actually have various node providers, right? And then in the case of Metamax, so this information from the blockchain is actually available via ROPC, right? So it is possible to set up a node, which is a very, very strenuous process, and then you are able to read data yourself and then be able to pass that data. So that is what we experience using Metamax.
Right. So Metamask is the one hosting the node. They're taking care of the infrastructure costs to host that node and run transactions through it with the application, with the wallet.
Exactly.
Cool. Okay. So awesome. I was, for those of you who actually followed along and actually set this up, welcome to Web3. This is your first, crypto wallet that you would have set up and made your first set of transactions, which is exciting. And of course, share your wallet address and share those tokens. This wallet address is kind of like your bank account. So, any digital collectible that you might, transact with or receive, that would go to that wallet address. It's basically going to be, part of individual identities going forward into the future, which is pretty cool. All right, let's. What's the second exercise now?
Great. So we just jump right into the second exercise, which is setting up Covalent and then using Covalent for carrying out transactions. Practically just to read on-chain data, to be very, very clear, just as we saw with Etherscan. So when using Covalent, it is very, very important to have an API key, because Covalent is an API that takes this data from on-chain, setting up multiple nodes to pass this data from multiple networks, and then be able to present this data in JSON and CSV formats, right? So for developers, what that means is that using the Covalent API, you can take this particular response, right, and then use that response, which is in very simple JSON, read it and build out applications out of it, right? And then for data analysts, you can still download this data, have it in CSV, and then be able to make sense of it and probably build charts, and all the use cases are just endless. The use cases are just endless. So the first thing that you want to do is go to the Covalent website, right? That's covalenthq.com. And then under the developer drop down, just click on free API key. So you have this very simple form that you are going to fill and then create an account. But in my own case, I am going to log in instead, as I already have an account. And then since this being a demo, the API keys I have on my dashboard, I am going to be destroying them after this. So when I sign in, oh, okay. Sorry, I think that there is an error with the sign in. But practically, when you sign in at this point, you are supposed to head on to, it's going to bring up the dashboard, and then you'll be able to copy an API key. I'm just going to go back into the demo and then show you the docs. So yes, this is the Covalent docs. I am very, very excited for this particular docs because we shipped this recently and moved away from the old docs to this, and this is way more intuitive, and the user experience is actually very, very great. So I mentioned earlier a difference between the Ethereum mainnet and then the Covalent testnet. So here are the list of chains on mainnets and testnets that are currently supported by the Covalent API. And here's the beautiful thing, right? So we have different blockchain platforms, right? Phantom, Avalanche, Ethereum. And during the demonstration in exercise one, when we saw the information on the transaction that we made, we had to go to Etherscan, right? And then for every other network here, they each have their own explorers. So it becomes a Herculean task for developers or for users to go to each network explorer to go get information on that about regarding that particular network, right? So what the Covalent API does is we index all of this data and provide it via one API where you can use all the endpoints to get whatsoever information that you need. And then using the docs, I am currently in developer mode, right? And this is just the overview where they explain to you what the API is. It's practically an API built using the REST protocol, right? And then we have three it's broadly classified into three classes, right? So the class A endpoints return data that are applicable to all blockchain networks that we index. And then the class B endpoints are specific to particular protocols on specific blockchain, right? Take for instance, Aave and also the Uniswap XY equal to K and the all variants of XY equal to K, from Pancake Swap to Sushi Swap to Spirit Swap. So typically, it's a REST API, right? That means all calls are over HTTPS. And then you actually have to set an API key. And then I am just going to, like, you can land on the docs and then be able to read up all of this information, right? And then I am just going to show you what next that we are going to do. We are going to get the token balance for that particular wallet address that you created, right? So we come back into the wallet, copy the address, go back to the Covalent docs, and then if you remember, I said the class A endpoints passes information across all networks. So we are going to use the get token balances for address endpoints. So all you have to do is
So I think the try it live will use the default, but if you click on the view parameters, you can see what was used to make that call, and I think you can paste your wallet address there. And as you're sort of going through this, when you had the drop-down menu beside the Ethereum mainnet, so you can see all the different networks that we support, there was like a little number in brackets next to each named network. So what is that number next to Ethereum mainnet with the 1 and the testnet Covalent 42? What is that?
So these are, you should think of these like plate numbers for different blockchain networks, and then they are actually called chain IDs. So plate numbers, every vehicle has a unique identifying plate number, right? That you would use to know, okay, this is this vehicle, or if you please, a unique serial number. So for every network on chain, there's a unique chain ID that when you are making calls to that particular blockchain network, then you pass in the chain ID, and then you return responses from that particular network. So as in this case, for the Ethereum mainnet, the chainnet ID is one. The chain ID is one, and then for the testnet, Covalent testnet, the chain ID is 42, and for the RSK testnet, the chain ID is 31, and each of these has a unique ID, a unique chain ID.
So I guess going
So
back to our example from exercise 1, we were
yes,
using the Coven testnet. So
yes,
we'll need to use the chain ID of 42 in this case here.
yes, exactly.
Okay, awesome.
So for the new docs, right? You when it was on Ethereum mainnet, you would see that the chain ID here it's set to one, and then it is on the Ethereum mainnet, right? So the moment I switch from the Ethereum mainnet to the Covalent testnet, it changes to 42, right? This is a default address that has already been pasted in here. I'm just going to paste the address that we copied from the wallet, right? And then click on run. So it has returned a response back to us, right? Quickly, I'm just going to look for the balance because that is what we are interested in at this point. Um,
Is that the value that you've got there?
I think, okay, yeah, get token. Oh, okay. So it is the get token balances for address endpoint. So what we are looking for is actually the token balance.
Cool. So I see that there. It's like the 4475. Does that match what Metamask was showing us?
No, it is actually a bit off.
Okay. So I think there's some correlation there, but how does the balance that we see there map to the balance that you would see in like we are seeing in MetaMask, for example?
So typically the balance is to be the same as you see on Metamax, right? And I think so. Practically, what has happened here is that it has counted the the zero decimals and then started from the first real number that isn't a zero, and that is the 44, right? So and that is the 0.004. So for a developer, right, you would be able to like take this number and then use, you could write a simple function, right, using one of the math methods to convert this to the required number of decimal places that the response ought to be. And this is in JSON, yeah? And you can simply change the format from JSON to CSV by switching the mode from the developer mode to the analyst mode. So that's it. Your balance returned via the Covalent API.
Cool. So maybe just to add just one more point to what you were highlighting there, Emmanuel. Thanks for that explanation. If you go back to the docs, so the fundamental unit for a network like Ethereum is in a unit called Wei, and one Ether is actually 10 to the power of 18 Wei. So the balances and any sort of native values that you see that get pulled from the blockchain are in a unit of Wei, which is with the 10 to the 18. So in order to get sort of the whole Ether unit, you need to take that value of the balance and divide it by 10 to the power of 18. And if you do so, and that's why I think in MetaMask it just keeps it to the 4 decimal places or 3 decimal places. So That's why you only see the first 4 of that number. But that's just how you map what you see from the data coming from the blockchain to what you might see in Metamask or another application.
Great. Thank you very much for that, Harish. Then going back, you can see that for the exercise 2, we have followed the steps at covalenthq.com /platform, or if you please, dropping down on developer and clicking on free and get API key to get your API keys, right? And then you come down to the docs so you can get to read the docs for yourself, see more endpoints. And then for this particular exercise, we use the get token balances for address, also called the balances v3 endpoint right now. And then we are able to use it to return the balance on our wallet. And like Harish mentioned, it is calculated in the unit of GUI, and then it is 10 to the 18th place. When you use the call the math function on that, you will be able to get the value as you would on Metamax. So back to the presentation. So for this hackathon that you are going to be participating in, I'm just going to share some few resources that you would find very, very useful during the course of your building. So we have 2 primary resources, right? And that is the Covalent docs and then the API reference, which we just, went through, right? So with these 2 documents, there is no limit to what you are able to build. And I would also add that it would help to go look over the project showcase. That way you would see all past projects that have been built using the Covalent API. So I'm just going to go into the docs and then just give a very quick high overview, right? I mean, the quick start page practically shows you everything that you find when you hit the API pages, right? But the section of this docs that is very, very critical, that you have to pay cursory attention to, is the Alchemist cookbook. That is where you find the tutorials on custom build technology called Primer that you will be able to use to make even more complicated queries when passing data, right? And then you have the how-to guides. This is where you will find the front-end guides on how to use basic front-end frameworks to consume the API, either using Axios or Fetch. And then you have the basics guide where you can see everything that you're able to do with a class A endpoints. And also one of my favorite parts too, the configure guides, where you would find the XYK equal to K methods and how to use all of that. So this is what you need to pay close attention to when you look over the docs. And then the project showcase, it's also on the docs. This is where you see all projects that have been built on top of the Covalent API, and you could find inspiration and then be able to build out even more. So we have already looked over the API docs, right? The class A endpoints, and then the class B endpoints. And then we also have the pricing endpoints where you can get historical token prices, right? Which means you could build out charts, dashboards, and whatever the mind can conceive regarding, what you can do with the API, it's limitless. So that's practically it for that. And yeah, that's it. You are good to go at this point. And from this end, I just want to say good luck and looking forward to seeing all the amazing things that you guys are going to be building. Thank you.
Awesome, Emmanuel. Thank you. And just the one last thing there to point out, we do host a bunch of code templates on Replit. So if you go to covalenthq.com/Replit and you join our team there, you'll have access to a whole host of starting templates to basically build either a basic wallet. If you want to try building an NFT sort of showcase or marketplace, there's a template for that. If you want to build your own sort of decentralized exchange, there's a template for that. So we've been building out these templates for the public to use. So I definitely recommend you go check it out. and try to see if you can incorporate any of those templates into your builds. So I think we got about 10 minutes here. Ben, I don't know how if there's a sort of a Q&A or if you've been sort of following any questions that have been asked, but happy to spend the last few minutes here just answering any questions if there are any.
And then while we are waiting for Ben to come on, I think I'm just going to remind everyone that you can please join the Discord channel. It is available at covalenthq.com/Discord. There you would find us and be able to ask all and any questions that you may have.
Okay, so I see that there isn't necessarily a QA part, so I am just going to show one more thing here before we break. So this was a project built out of one of the hackathons that we run, and just to highlight the creativity of our developer community. This is basically I just crashed the app here. But basically, it's an NFT gallery that was sort of created in a format where all the digital collectibles for a particular wallet address are actually presented through this walkthrough. Let me see if I can not embarrass myself here and actually walk through. All right. So here, this particular collection of digital collectibles for this wallet address are being presented in a digital art gallery here. So imagine if you're able to, use your own sort of artistic skills and build something that you want to share, and then have your own collectible in this 3D format where, participants virtually can walk through, they can take a look at your artwork, they can bid on it, they can purchase it, of course. And maybe you can add in some gating mechanisms where sort of buyers of particular NFT collectibles then get access to other events and other marketplaces. So the sky's the limit in this place, in this digital world, where value is shared amongst the builders and the consumers and users of a particular network. So let your imaginations run wild, and good luck with your builds. And thank you so much for having Emmanuel and myself here to run this workshop with you guys.